and good evening. I hope you're all doing very well. Welcome back to TechnoClub's Thursday Code Club. It's been a little while since we last met. I had a nice holiday. A nice holiday sat at home, but still, a holiday nonetheless. I'm going to start this session by reminding you that next week we begin our Summer of STEM. We've got several activities planned, 15 days of science, computer science, maths, technology, engineering, all that stuff, and all free to sign up to. And we're also running in the evenings on some of those days some more advanced computer sciencey stuff. Great fun. I recommend signing up. I'm going to stick a link to the sign up in chat for anyone who's interested. If you complete a certain number of these sessions, there is a small reward available. So if that's something that interests you, have a go at that link. No, it decided not to send. Let me try that again. Blooming technology. There we are. So, with that out of the way, let's talk about what we're going to be doing today. So, last week, well, I say last week, 2 weeks ago, I confessed my love for a particular style of art from the artist M.C. Escher, who used to do lots of impossible geometric stuff. Things like this. It's a staircase, but if you follow the people walking around it, they are always going up. And, well, how on earth can this be achieved? Well, Escher used a little bit of interesting geometry, and this is referred to as Penrose Geometry, because it's impossible in real life, but it is possible in 2D on a computer. And there's other things that take advantage of this. This is a screenshot from the game Monument Valley. It's a very good game. And you can see that. How on earth does this path work? That's just maddening. How is that even possible? And you can get from one layer to the top layer whilst they're being connected. It hurts the brain. And these are both examples of Penrose geometry. And the most well-known of these is the Penrose triangle. And we're going to draw this, but we're not going to draw it by hand. We're going to draw it programmatically. And for that, we're going to use Python. So if you head to the link, repl.it, it's a very unusual name for a website, I'll admit. I don't even know how to pronounce it, just repl.it. I've also sent a link in chat. This website's brilliant because it lets you program in practically any language from your browser. So you don't need to install anything. It's brilliant. And today we're going to be using Python. So if you go to that link and click Start Coding, it'll ask you what language you want to start coding in. Now, we want to code in Python, but we want to code in a version of Python that supports Turtle. So don't click on Python. Instead, type it in. And you can see that there are several versions of Python. We've got Python, Python 2.7, Python with Turtle, Pygame, and tkinter. The one we want is Python with Turtle. And we're going to create REPL. Such an awkward word. Give it a moment, and it should load in. Nice and good. There we are. Can I zoom in? I'm just going to zoom in to make it a bit easier to see what I am writing. So, what are we doing? Why are we doing this? Well, we're going to use the turtle library to draw our Penrose triangle for us, but we're going to do it in such a way that we can actually tell our program what size Penrose triangle to draw, and it'll draw it automatically for us. We're going to parametrize. That's a word I can never say. We're going to make this parametric. So before I do that, let me show you the easy way you can draw a Penrose triangle. I used to doodle this in my history textbook and then get told off. So there's a fun story. If you ever want to draw a triangle in real life now, not using Python, then it's quite simple. You start with the short side at the top, and then you need a long side. This isn't going to be very good, but this is just me showing how it can be done. So you've got a short side and a long side. You need another short side, that corner. You need another long side. You need another short side, and need another long side. So what we basically have is a normal triangle with the corners cut off. Once you have that, we need to start drawing the internal lines. So you start at one of the corners of the short side, and you draw a line that is parallel to the long side. You don't want it going too far down. You want it to be kind of 3/4 of the way, maybe 2/3. And you need to do that for each 2 other corners. And you need to do it for the left corner there. If you've done it for the left corner here, you do it for the left corner. Or the... Let me just show it, it'll become obvious. I'm going to repeat this line using the mirrored corner here. I'm going to repeat it using this one here. And you should have something that looks a little bit like a recycling symbol. And what you have to do is you just need to put one more straight line in for each of these. So one goes in there, one goes in there, oops, and one goes in there. Okay, so my version wasn't very neat, but we're going to be able to draw this perfectly in Python. And when I say perfectly, I mean perfectly. So, we're back into REPL.it. Let me maximize that. The first thing we need to do is we need to tell Python that we're going to use a turtle. And to do that, we use the keyword import. And after it, we tell it what we want to import. Well, we want to import a turtle. Nice and simple. Let me, a bit bigger. Now we need to give our turtle a name. Now, I always drum into you lot that it needs to be a sensible variable name. But, that's effort. Let's just do something silly and stupid. Let's call our turtle... Any suggestions in chat? My imagination's gone. Let's call our turtle Simon. So I need to tell Python that that Simon is a turtle. So I'm going to say Simon becomes equal to turtle. And that seems fine, but that's only the first part. We need to say, where does the turtliness come from? So we need to say turtle dot turtle with a capital T and an open bracket and a close bracket. And if you've done that right, the second turtle should be purple. So Simon equals turtle with no capital, dot turtle with a capital T, open bracket, close bracket. Now, this is where we can add some features to our turtle. We can do interesting things. We could say Simon dot, let's make him incredibly fast. We could say Simon dot speed 0. Now, funnily enough, if you type in 0 for the speed there, it will go as fast as possible. 0 is the fastest speed. Doesn't make much sense, but when you type in 0 there, it defaults to the fastest speed. If we wanted more, we could also do Simon dot, let's say, color. Now notice I spelled color the American way. The American way is C-O-L-O-R. There is no U. And that's because this library, this turtle library, was written by an American. So we have to unfortunately use their version of the word. I could say Simon.color, and then in brackets, I can name a color. And because it's a piece of text, it needs to be surrounded by speech marks as well. So I could have it red, and Simon will be red. I could have it blue, Simon will be blue. I could have it purple, Simon will be purple, and so on. Now let's just be boring. Let's just go black for now. Now you don't have to do this, but I'm going to do this to make things a little bit easier to see on stream. I'm going to change the width of Simon. I'm going to make Simon a little bit fatter, just so we can see better. So Simon.width. And in here, I need to give a number that represents the number of pixels wide that Simon is. Let's say 3 for now. I might tweak that in a bit. We'll see. Okay, so we've spent 5 lines just setting up our environment. Now we can actually get down to the nitty-gritty and start giving Simon some instructions. Now, I'm going to glance over this because I've done Turtle before, and there's only 2 instructions we need, and it's just different combinations of those instructions. We've got forward, which moves the turtle forward, and we've got right, which turns the turtle a certain number of degrees. So if I were to go Simon.forward, I need to say how much Simon's going to go forward. If we go back to our Penrose triangle, I'm going to do this top line first here. So this needs to be some amount. And it's going to be shorter than this line here. So let's just try Simon.forward 50. And he's going to move 50 pixels forward. And if I press play, we should see that has happened. We've now got a line that is 50 pixels long. Let me just take out the speed line so we can actually see it animate. I'm just going to delete that speed. No, it still did it. Oh well. Simon.speed. Let's try the slowest speed of 1. There you are. You can see him moving along as he draws his line. Okay, let's move. Let's start doing the next part. Let's turn Simon to the right. And for that, we need to know what angle this is. In fact, let me get a little pen out. And that'll do. We need to know what angle this is. How far do we need to turn right? Actually, no, it's not that. It is my mistake. If we imagine the line carries on like this, we need to find out what for goodness sake, I've lost my pen. We need to find out what this angle is here. So, I've already done this. I know that angle is 120 degrees. I'm not going to go on about it. This isn't a maths lesson. I'm just going to say Simon.right. It's not 120, is it? Oh, goodness sake. It's 60 degrees. I'm going to say Simon.right 60. And he's going to turn 60 degrees. And afterwards, I can have him go forward a bit more. So Simon.forward, let's say 200. So it goes forward, he turns right 60 degrees, and he goes forward 200 degrees. Sorry, 200 pixels. And we've got the first two sides of our Penrose triangle. So, what should we do? Should we just copy and paste the rest? No, we're going to do this professionally. We're going to make this the best piece of Python code you've ever seen. So we've got to fix a couple of things here. The first thing is, if I wanted to repeat this 3 times, I would have to. Then I could just copy and paste these out 3 times. Ooh. Wrong key combo. Nope. There we are. We could copy and paste it out. And when we watch it, it'll draw the whole thing quite slowly. Ooh. I forgot to put an angle in there somewhere. Where did I forget to put my angle? Oh yeah. It needs another 60-degree turn at the end of each little bit. I mean, I could write them all out like that. And when we watch it, it will move along, do its thing, keep turning, and it'll carry on drawing. That's all fine. But say someone came along now and said to me, okay, I want the same thing, but I want it bigger. So you think, okay, well, that's simple. I'm just going to change all the numbers here. So let's make the short side bigger. Let's make that 100. Let's make that side bigger. Let's make that 300. Let's make that one 100. Let's make that one 300. Let's make that one 100. Let's make that one 300. Can you see what I'm doing? I'm having to go through every single line and change those numbers to the same thing. And that's not very good because we're only dealing with 10 lines here. Imagine we were drawing a shape with 300 lines. Would you want to go 300 lines, line by line, changing every single number? No. So that's why we use constants. Constants will store that value for us and allow us to change it and allow a programmer to come along and change it at a different point in time. A constant is just a variable that you shouldn't really change. So what we're going to do here is we're going to create a variable And that variable is going to store the size of the length of the short side. So let's call this variable short side. And I'm going to set it equal to, let's say, 50. Now, I did a little bit of experimentation earlier today and found that there's actually a formula to get the perfectly proportioned shape Penrose triangle. And it's all to do with a ratio between the short side and the long side. And you'll find that things work best when the long side is 4 times the size of the short side. So rather than do that maths in my head, I'm going to create the variable long side, and I'm going to say it is equal to short side times by 4. And to get a times, I use an asterisk. And then, how much do I want to times it by? 4. The long side is 4 times the short side. So, with that in place, I can start replacing all of these numbers with variables instead. So that when I change it up here, I don't have to change it in these as well. So let's change that one to short side. Let's change that one to long side. Let's change that one to short side. Talks amongst yourselves whilst I'm doing this. Long side. Short side. Long side. Okay. So if this one's 50, if the short side is 50, then times by 4, we get the long side equal to 200. So when I click play, it will draw that all out for me, and it'll be using the numbers stored in the variables rather than anything else. Let's wait for it to finish, being agonizingly slow. There we are. I'm going to change its speed back because I want to finish this the same age I started it. Yeah, so it just draws that instantly now that I've set it to 0. Okay, that's all well and good, but what's the benefit of being able to set the short side and have the long side automatically valued? Well, if I change the short side to be a different size, let's say 15, it'll automatically draw it perfectly proportioned because it'll just do short side times 4. I can make it huge, like 100, and still it's got perfect proportions. Okay, so we've tackled the first nasty bit of code. Let's tidy this up some more. Now, any good programmer should be able to spot that we're basically doing short side right 60, long side right 60. And then repeat, short side 60, long side 60. Repeat, short side 60, long side, and there should be a final term right at the end. Why do I write out all that code when I could get it to repeat for me? So what we're going to do is I'm going to delete the repetition, and I'm going to make this happen 3 times. And so you've guessed it, we're going to use a loop. And the easiest loop to use in Python is a for loop. So I'm going to say for. Now I need a counter variable. This variable is going to count how many times we've been around. So let's call this count. For count, well, I want to say what point it stops. So if I want this to happen 3 times, I want it to count from 0 to 3. I want count to become 0, become 1, become 2, and then stop before 3. So I need a range. I need that range from 0 to 3. So I'm going to say for count in range. Now, inside these brackets, inside range, you would put the range that you want it to count. It could be 1 to 3, it could be 7 to 3 million, it could be 8 to, I don't know, 12. But if we put one number in there, it defaults in being to 0 up to that number. So if I say in range 3, it'll do 0 to 3. If I put that to 10,000, it'll do 0 to 10,000. But we only want it for 3. So for count in range 3, I need to finish off my for loop, and I'm going to do that with a colon. And as soon as I press enter, we'll see that it's moved our cursor away from the edge. That's because Python is what is known as a white space delimited language. What that means is you can tell what belongs to what by how much white space is in front of it. This is referred to as white space because it is a blank, empty space that is white. So at the moment, this chunk of code here is outside of our loop. It's not going to be counted inside our loop. It's not going to happen. It's not going to happen 3 times. And that's because there is no white space in front of it. And to put white space in front of it, I click my cursor in front of it and I can press tab. And we can see that's decided to put it inside the for loop for us. There is a shortcut for that. If you've got multiple lines of code and you want to move them all inside at the same time, you can highlight it all and press tab, and it will put white space in front of all of them for us. So you should have a for loop that looks almost identical to this. And we can tell it still works because when I press play, it still completes the drawing for me. It's a little large at the moment, so I'm going to take down the short side to 50 again. And we've managed to draw the same thing in 1, 2, 3, 4, 5 lines of code rather than 10 lines of code. So you can see why programmers use that. It stops us repeating code. Now, of course, back in the days of retro computers, you would only have enough memory to be able to store 100 lines of code. So every single line counts. Nowadays, you can store billions and billions of lines of code, and it doesn't matter. But if we don't clamp down on making things neat and tidy, we end up with something called spaghetti code. And we don't want to go back to the days of spaghetti code. So that's why we've got these practices in place. We like to make things neat, and we like to make things happen with repetition rather than lots of lines that are the same. Anyway, we've pretty much finished the first part of the Penrose triangle. We've got the outer exterior lines. How on earth are we going to do the interior lines? Now, when I draw my Penrose triangle by hand, wrong button. What I tend to do is I'll draw the outside like this, and then remember when I was talking about jumping to these points? What I will actually do is lift my pen off the paper and I will physically move it to these points so I can draw a line there. So I drew one line there, then I jumped to that point and I drew a line there, then I jumped to that point and I drew a line there. Which is all well and good, but how do I move my turtle? Now, on the next few lines, I've just pressed enter a couple of times, then backspace. I pressed backspace because notice how it kept some white space in there for us. So I want this to be outside of the for loop, so I make sure to press backspace so when I type, it is outside the for loop. There is the command. I could tell my Simon to just go to somewhere. I could say Simon dot go to, and then open bracket, close bracket, and inside that I could give it the coordinates of where it goes. I could say, let's go to 117. When I press play, that's what it did. It started here and it went to the position 117, which is over there. If I went minus 170, it would go. Oh, that's not what I intended. It looks like I've drawn it perfectly. I didn't mean to draw it perfectly. Ignore that. Let's change that to, I don't know, 60. And let's make that minus 300. Let's change the speed again. So when I tell it to go to, it will literally move itself on the page to where I go, and it'll draw a line as it does so. Which, well, that's great if we know where we're going, but what is the position of this point here, for example? We just don't know. So what we're going to do before that is we're going to, as we are drawing, store the positions of these points. So I'm going to get rid of that go to statement because it was a load of gubbins. And I'm going to look back inside my for loop. What I want to do is I want to add each corner point to a list of corner points. So I know that I can revisit those corner points. I can actually move to them later. And to do that, I'm going to create a list, or otherwise known as an array. So this needs to happen before the for loop, because if it were inside the for loop, I would be creating the list every time the loop iterates. So I'm going to actually write this underneath my short side and long side declarations. And I'm going to give it a stupid name, something like, I don't know, coordinate list or chord list. It's the list of the coordinates of each of those points. Now I need to tell Python that this is a list and it's an empty one. So I say equals. And for this I use square brackets because square brackets in Python denote a list. So open square bracket, close square bracket. I've now made an empty list called coordinate list or chord list. What I need to do now is, after it's drawn every short side and long side, I need to add where it ended up to that list. So inside my for loop, underneath the last instruction to turn right, I'm going to add something onto the end of my coordinate list. So I say coordinate list with a capital L. And the keyword to add something onto the end is append. A-P-P-E-N-D. Because you're putting something and you're applying it to the end of the list. You're just sticking it at the end of the list. And that has a open bracket and a closed bracket afterwards. And I have to ask myself, what am I storing in that list? And what I am storing is the position of my turtle, Simon. So let's do chord list.append Simon dot position. We are getting the position of Simon. And that is followed by an open bracket and a closed bracket, because position is a function of Simon. Now, if we wanted to, we could actually print off each of the coordinates. If underneath that I type print, I could actually print the coordinate list. I could print chord list. And every time it draws a short side and a long side, it will print the list. And we can see what it builds up as. Let's click play. Okay, so it's a little bit confusing to make out, but it actually printed them for us. This is the list after it hits the first one. We can see that the coordinate of this point here is 150 minus 173. And then when it hit this point here, we can see it added it on to the end of the list, where we've still got 150 minus 173. Now we've got minus 75 minus 216. And then this position here is 0, 0, because that's where the turtle started up. So we can actually see the list being built in real time, which is great. But that's just a little bit of extra information for us. It's not necessary. Now, on the next few lines, I'm going to press enter a couple of times and backspace to take me out of the for loop. We need to get our Simon, our turtle, in the right position to go ahead and carry on drawing. And if we look at where he ends up pointing right. And if we want to start drawing from this one down here, it needs to be pointing the other direction. So I want my Simon to turn around 180 degrees. So Simon dot right 180. And that should turn it around completely. And after I've written that, I can start writing the interesting part. What we're going to do is we're going to say for each position in the coordinate list, I want Simon to go to that position and start drawing. So, how are we going to do that? Well, we're going to use a special kind of for loop. This was a for in range loop, this one we wrote up here. This is going to be a for each loop. And it's in English, it goes as for each item in the list. But in programming language or in Python, it is for the name that you want to call each item. Well, what are these? These are coordinates. For each chord in chord list. Colon, enter. Notice that I say for each chord in chord list, even though we can't see an each there. It is just for chord in chord list. Now, I don't know why the developer of Python decided not to put the each in there, because it just sounds so much better for each chord in chord list, but it has to just be for chord in chord list. Other languages may do that differently, but this is Python. We have to stick to its rules. So when I say for each, it's not there, but just imagine it there. For each chord in chord list, what am I going to do? Well, I need to move Simon. But if I move Simon, he's going to carry on drawing and scribbling all over the page. So I need to lift the pen up. I need to say Simon dot pen up. And that's all one word. And it ends in an open bracket and a close bracket. And basically that tells Simon to just stop drawing. Now I should be allowed to go to my coordinate. And the keyword for that, we saw it before, was Simon dot go to, all one word, Simon dot go to. Where do we want him to go to? Well, we want to go to the chord that we are talking about, the coordinate. So we want to say go to chord. And once he gets there, he should put his pen back down again, so we can actually start drawing. So Simon dot pen down. Notice pen down is all one word, and I have an open bracket and a close bracket. Let's watch this just to see whether things work. Nothing will be drawn, but let's just see where Simon is going. So he's drawn the thing, then he goes to each corner. That was a little fast. I'll change the speed back down. Let's watch it. So he does what we've already told him to, and then he's going to visit each corner. There we are, he's visited them. He didn't draw anything, but he visited them. So now that means we can get on with the drawing part. Now, this took me a good day and a half to work out the maths, and I had to get a ruler out, and it was just a huge pain. But I worked out that the distance of this line here should be 80% of this line. And the reason is we use 10% as the distance here and another 10% as the distance here. So 100% minus 2 10% gives us 80%. So how do we get 80% of the side of the long line? How do you get 80% of long side? Well, let's just get Simon moving first. We say Simon dot forward, and we want 80% long side. So that is long side. Let me just spell it right. Now, to get 80%, it's easiest to times by 0.8. So if you times by 2, that gives you 200%. No, sorry. Yeah, that gives you 200%, I think. 100. That gives you double. But if you times by a decimal number, it'll actually go the other way. It'll get smaller. So long side, asterisk for times 0.8. And that will give us the perfect line. And if we click play, you can see it draws out the main exterior. And then it goes to each point and draws. Oh, wait. Oh, no. Oh, it's gone off and started drawing a prism. That's okay. We've just missed an instruction. if it draws this line and then it goes to this point, we need to know the right rotation from this point to go upwards to the right. So if this angle here is 60 degrees, then it must be 2 times 60 degrees, which is going to be 120. So Simon.right 120. Let's watch that. It's going to do the long side, then that one, then that one. And there we are. That looks pretty spot on to me. So we've done the long sides. Now we need to do the extra internals. So let's say I get to this point. What should I do next? Well, I need to go forward a certain amount. And again, this is a ratio I needed to find out myself. We need to actually go forward 35% of the long side. So underneath, Simon.forward. How much are we going to go forward? Well, we're going to go forward by the long side, but we need 35% of the long side. So long side times 0.35. If 0.8 is 80%, then 0.35 is 35%. And that's easier to make it obvious if I type the 0 after the 8. So it's just 80, but after the decimal point, and 35 after the decimal point. Why is it 35? I don't know. It's a very awkward number. I don't even begin to confess to understanding maths. I just found it by trial and error. And now I hope it works, otherwise I'm going to start looking like an idiot. Okay, there we do the little extra bit. There we are. And boom, we have a Penrose triangle. I'm glad I got that right in the end. Let's just tidy up a couple of things. Let's get Simon out of the way, because that's annoying. No, let's leave it there. Let's focus on what I said we would do at the start. Now, at the start, we said we'd make this parametric. And what that means is someone could come along and say, okay, draw me a Penrose triangle, but make the short side, I don't know, 500, or 5, or 7, or 82, or a Googleplex, or whatever. So we're going to wrap up everything we've written so far and turn that into a function that anybody could come along and use, any other programmer. So, where do we start? Well, we need to start after we finish the setup. So we need to leave this as is. We need to leave Simon equals turtle.turtle, leave that all the same. Where do we start writing our function? Well, we start writing it before short side. And the key word for Python functions is def, because we're defining a function. I need to give my function a name. I'm going to call that, I don't know, draw Penrose. And because it's a function, it has a open bracket and a close bracket afterwards. And as with every bit of structure in Python, it ends in a colon. Now, what needs to happen next? Well, remember in Python that everything has to have white space in front of it if we want it to be inside something. You know, the distance from the left signifies what thing is inside what thing. So at the moment, all of this has no white space in front. I want it to be inside def, so what does that mean? I need to put white space in front of all of these things, even if it already has white space in front of it. Because if I white space the 4, then now Simon is outside of this 4, so I need to white space the Simon again. But as I said at the beginning, there's a simpler and easier way to do that if we just highlight everything and press tab. And it's done it all for us. Two last things as a little bit of cleanup. There is no point in making this a function if we tell the function what short side is, permanently. No one can come along and use draw Penrose and change what amount. So when it says short side equals 50, I'm going to delete that. I'm going to just get rid of it. And instead, I'm going to turn that into a parameter. And the parameter is what gets set when we call this function. So I'm just going to type in here short side. So if you look here, when we've got long side equals short side times 4, that's no longer referring to the number 50. That's referring to whatever we send to the function draw Penrose. This short side now refers to this one, which is the parameter. Okay, when I click play, well, now nothing happens. That's because we haven't called our function. Now, in Python, functions are always written at the top, and stuff that's outside a function gets written at the bottom. This is because Python needs to read the function at the top first. It'll absorb all that, stick it in memory, and then down at the bottom, where you call it, then it'll be able to recall from memory. So I'm going to go down to the bottom and I'm going to press enter a couple of times. Now, we need to make sure that we've got the right amount of indenting before. If I start typing here, we can see that it's still inside this for loop. We don't want that, so we need to go back a white space. Hang on, it looks like we're still inside our function. We want to be outside our function now, so we need to go back a white space again. So always look at where you're typing and what it belongs to. And it's under here that I can actually reference my function. I can say draw Penrose. How much do I want? How big do I want it? Well, this is where I pass the value of the short side. I give it however much I want. So I could put in 500. And when I click play, it'll draw the whole thing. As you can see, absolutely massive. I'm going to stop that because that's going to take ages and make that speed 0 to be fast again. And we can see it's drawn it absolutely massive without having to tweak any of the numbers inside the function. If I change that down to 5 and click play, we can see it's done it absolutely tiny. I could have 15, get it a little bit bigger. I could have 100. There we are. Let's tidy this up a little bit more, make it even neater, just in the last 5 minutes or so. If I delete what I've just written, and instead I replace my function call with a question to the user, I could say, user, what size do you want me to draw this triangle? this Penrose triangle. So to do that, I could have, well, I need input from the user, and to get input, I need to store the input. So I'm going to have a new variable called user answer, because this is what the user answers. And I'm going to say user answer is equal to, now I need the Python function to grab the input from the user. And that is as simple as input, and then in brackets and speech marks after the input, I put in whatever phrase I use to ask the user. So, what size do you want your Penrose triangle? Question mark. And on the line after that, well, what can I do with that? I could, well, I need to call my function draw Penrose. I could just, I don't know, put in the user's answer. I could say draw Penrose, open a bracket, and inside there I can just stick the user answer. So whatever the answer will be sent straight away to the function. Let's click play. And we can see down here, it asks me, what size do you want your Penrose triangle? And we're going to hope that the user puts in a number. Let's put in the number 30 and press enter. And, ooh, what have we done here? Ah, we've got an error. And it says, can't multiply sequence by non-int of type float. And what that basically means is, when we've done the timesing here, the multiples, it's saying, I can't times something a user's typed in. For example, if I were to run this again, and I were to type in the size, I don't know, sausages, it doesn't understand what sausage is. It says, how can I times a sausage by 0.8? I don't understand. So what we need to do is we need to do a fun little bit called casting to an integer. We need to turn user answer into a number, or in computer science terms, an integer. And we do that with the keyword. Oh, hang on. Is that correct? I'm just seeing if this is right in Python. It might be wrong. You do that by typing int, open bracket, user answer, and then a close bracket after the user answer. So basically, int takes user answer and turns it into an integer. I hope I might be confusing this with Java. That's fingers crossed. It's been a while since I've casted to an int in Python. Oh yeah, it was fine. It all worked. So yeah, int plus the user's answer will convert the user's answer into an integer. And that will work nice and fine. And if we run it again, like I say, what size do you want your Penrose triangle? Let's make it something stupid, like, I don't know, 1000. And there we are, it's drawn it for us, although we can't see on the screen. If I run it again, let's choose something sensible. Let's say 60. And there we are, it's drawn it for us. So, I hope that has been a nice, enjoyable little thing to do, making these. If you wanted to really challenge yourself, you don't just get Penrose triangles. You also get Penrose squares, Penrose pentagons, Penrose hexagons, Penrose octagons, and so on and so on and so on. There's lots of different ones you can try. Good luck with the maths on that. I wouldn't be able to do it, so I'm sure there are people out there who can, just not me. Other things you can do. Maybe you could have a little extension here where you ask them what size they want their Penrose triangle, and then you ask them what colour they want it. So I could say user colour equals input what colour do you want your triangle, and then you set the colour of Simon depending on their answer. Anyway, that is all from me today. I shall just remind you, there is last week I set about a survey for anyone who wanted to suggest new things that they want me to cover, and also anything they wanted to challenge me to do. And I've got a couple of responses. Someone has challenged me to make an entire 20-level game that's similar to Legend of Zelda. I'm going to take them up on that challenge, but I'm going to work out when to do it, when's best. If you want to give me any challenges like that, or if you want to see a particular technology or a particular guide on anything to do with computer science, the place to go is bit.ly/codeclub-survey. I'm going to put that link in chat. bit.ly/codeclub-survey. And if you fill that out, then there is a good chance, if it's nice and sensible, that I will take you up on your offer and I will cover whatever you want me to cover. Anyway, I hope you enjoyed that. Have a very good evening. Don't forget that summer school starts on Monday, the 3rd of August. That's this Monday coming. You can still sign up. You can sign up at any point. We're never going to say, no, you can't sign up, you've been too late. You can sign up even on the last day, and we won't mind. Sign up, choose what sessions you want to attend, and yeah, enjoy your summer. Goodbye.